Example 5, finding the equation of a tangent line. It says find the equation of the tangent line of the graph of y equals x squared minus 4 all over 2x plus 5 at the point 0, negative 4/5. Well, we told you we need a point. Sorry, let me get my pen. We need a point. We need the slope, which again is going to be y prime at x equals 0 in this case. And then 3, we're going to plug it into y minus y1 equals m times x minus x1. The point slope formula, and solve for y. So that's our strategy. Well, what's the nice thing? They've already given us the point, haven't they? The point here is the point 0, negative 4/5. Of course, if they just gave us 0, we could have plugged it in and gotten negative 4/5 really quick. But they did actually give us the whole point. So now we need to find the slope. So how do we find the slope? We need to find f prime of x, or in this case, y prime. Well, notice that it's a quotient. Y is equal to x squared minus 4 over 2x plus 5. It's a quotient. We can't separate and simplify this, so that means we're going to need to use the quotient rule on this. So if we're using the quotient rule on this, go ahead and write down the quotient rule. It's low d high minus high d low over what's below squared. Low d high minus high d low over what's below squared. So let's give this a chance. Let's figure this out. What's the low function? The low function is 2x plus 5. So what's the derivative of the low function? The derivative of 2x is 2 times 1, which is just 2. And the derivative of 5 is 0. So that's our derivative of our low function. High function would be x squared minus 4. The derivative of the high function, derivative of x squared, is a 2x to the first, which is just 2x. And the derivative of negative 4 is 0. And remember, it's going to be low d high minus high d low over what's below squared. So let's go ahead and plug it in. Low is 2x plus 5 minus the derivative of the high, times the derivative of the high, which is 2x, minus the high function, which is x squared minus 4, times the derivative of the low, which is simply a 2. And this is all over the low squared, which would be 2x plus 5, quantity squared. I need to clean this up. So I'm going to distribute through the 2x, and I'm also going to distribute through the 2. Okay? So let's see if we could do this. Y prime would then equal 2x times 2x is 4x squared. 2x times 5 would be a 10x. I'm going to go ahead and distribute the negative and the 2 in two cases. So I'm distributing both the negative and the 2. So it's negative 2 times x squared would be negative 2x squared. And then it's negative 2 times negative 4. Notice it's a negative 2 times a negative 4 would be plus 8. So I'm distributing the negative. Never forget to distribute that negative to both terms. Remember, you're never distributing out the bottom. Always keep the bottom in factored form. So that's 2x plus 5 quantity squared. 4x squared minus 2x is, what is that? That'd be a 2x squared. And then we still have that plus 10x and the plus the 8. All of that is over 2x plus 5 quantity squared. Again, this is just the derivative. We don't really care about the derivative. We care about the derivative evaluated at the point when x equals 0. So let's look at that at x equals 0. At x equals 0, that would be 2 times 0 squared plus 10 times 0 plus 8, all over 2 times 0 plus 5 quantity squared. So it looks like on top I'm getting an 8, right? On bottom I'm getting a 5 squared. Isn't that 25? And that doesn't simplify. So what's that mean? That means my slope is 8/25. So let me come back up here. My slope is 8/25. So now I need to do that step 3, which is actually find the equation of the line. Y minus y1 equals m times x minus x1. Well, in this case, we would have y minus my y value, which is a negative 4/5. So I'm going to change that to plus 4/5. When you subtract a negative, it turns positive. Again, my slope here was 8/25. And then I have my x minus my x value. That's nice because that's a 0. So this would be y plus 4/5 equals 8/25 x. Subtract 4/5 from both sides. And I end up with y equals 8/25 x minus 4/5. Again, this is something that we could use Desmos to help us verify our answer here. In Desmos, you could graph the original function of x squared minus 4 all over 2x plus 5. Then in the second one, you would graph y equals 8/25 x minus 4/5. You should see some shaped graph with, a curve or something, but you should see both of them going through the point 0, negative 4/5. This one is a straight line, and the slope of the tangent line that we just found should be the slope of the graph at that point. Okay, let's move on to example 6. It says rewrite before differentiating. Find the derivative of 3 minus 2 all over x plus 4. So this is where we have compound fractions. If you looked at the algebra review, you found out multiple ways of doing compound fractions. One way of doing compound fractions is by looking at just the top, just the bottom, finding a single fraction, and then you keep, change, flip. That's a multiple step process. Quite honestly, the easiest way of solving compound fractions oftentimes, not always, but oftentimes, is just multiply everything by the denominator. So the only denominator we see here in the individual tops and bottoms is just this x right here. So what I'm going to do is I'm going to multiply every single term on top and on bottom times x. So let's see what happens when I do that. The reason I can do this is because I'm doing it on top and bottom. So effectively what I'm doing is multiplying by x over x, which is just the number 1. So that's perfectly okay mathematically for us to do. Why I do this is this will eliminate all fractions. So on top I have x times 3, which is 3x. Minus 2 over x times x. Well, the x's simplify, so that would just be minus 2. And on bottom, I'd have x times x, which is x squared, plus 4 times x, which is 4x. So the beauty of multiplying each term by x is it gets rid of all denominators in one step. If you look at the solutions, I am going to have a different way of doing it, and that's where I find a single denominator on top, a single denominator on bottom, and then I keep change, flip. I multiply by the reciprocal, okay? So that's our original function y, and we want to find y prime. Notice this is a quotient. This is a fraction is what I was going to say. So we have to do the quotient rule. So that's low d high minus high d low over what's below squared is what we're looking for. The low function here is the bottom, which was x squared plus 4x. The derivative of the low function then, the derivative of x squared is 2x. The derivative of 4x is 4 times 1, which is just 4. So the derivative of x squared plus 4x is 2x plus 4. The high function here is 3x minus 2. The derivative of the high function, 3 times the derivative of x, which is 3 times 1. 3 times 1 is just 3. And the derivative of minus 2 is 0. So the derivative of 3x minus 2 is just 3. Remember, we're going to do low d high minus high d low over what's below squared. So the low function is x squared plus 4x. Derivative of the high is a 3. Minus the high function, which is 3x minus 2, times the derivative of the low, which is 2x plus 4. And then all of this is over the low function squared, which is x squared plus 4x quantity squared. I do not want to distribute that or FOIL that out. I could factor out an x, but I don't know if we need to. We'll wait until the very end to see if that would help us at all. So now I'm going to work in the numerator. I'm going to distribute that 3 through to both sides. And then I'm also going to FOIL this out in the 3x minus 2 and the 2x plus 4. I'm going to do this in 2 steps rather than trying to distribute the negative all in 1 step. I want to make sure I don't make those algebra errors, so I'm actually going to do it in 2 steps. So I have 3 times x squared, which is 3x squared. I have 3 times 4x, which is plus 12x. And then let's do minus, and I'm going to do this all in, it doesn't matter if I do parentheses or brackets. So I'm going to do 3x times 2x. I'm FOILing it out. 3x times 2x is 6x squared. 3x times 4 is plus 12x. Minus 2 times times 2x is a minus 4x. And minus 2 times a positive 4 would be a minus 8. So combining that, 12x minus 4x, that would be a plus 8x. Okay, now I need to distribute the negative through to those three terms. But remember, all of this is over, I apologize, x squared plus 4x quantity squared. But now I can distribute that negative. So let me come down here. Again, remember we're working with the derivative here. On top I'd have 3x squared plus 12x. Looks like I'd have a minus 6x squared. Distributing the negative, I'd have a minus 8x. And then I would have the positive 8, changing the sign of each one of those terms. All of this is over x squared plus 4x quantity squared. We now combine like terms yet again. 3x squared minus 6x squared, well, that's a minus 3x squared. 12x minus 8x, that's a plus 4x. And then we have that plus 8. All of this is over x squared plus 4x quantity squared. I might be able to factor out that numerator. I could use the quadratic formula or try AC factoring to see if that numerator factors. I don't know if it does, but one thing that I do know for sure is it's not going to simplify any further because it doesn't have any common factors. It doesn't have essentially an x plus 4 or an x as a common factor in the top. Those are the factors of the denominator, by the way. So nothing's going to simplify. There's no need to distribute out that bottom. There's no need to factor the numerator. Let's go ahead and leave that answer as it is and make sure you put your answer in the answer blank.